Hey everyone, I'm excited to share that we've released the world's first fully managed serverless reinforcement fine-tuning solution. If you've been following Predabase, you've noticed we've published a lot of content recently about reinforcement fine-tuning. And in particular, we found that it's useful for really hard reasoning tasks where LLMs out of the box may not perform as well. One good example of this is Countdown, which is a data set in a game where an LLM and model needs to be able to take in a number of different input numbers and combine them using a mathematical equation it comes up with to generate a target output number. Now, it's pretty hard for LLMs to write equations and do math, so this is a perfect candidate for something like reinforcement fine-tuning. What I'm going to do is show you a little bit of how you can kick off reinforcement fine-tuning jobs using GRPO in just 60 seconds inside of Predabase. Now, the first thing you want to do is create an account inside of Predabase, which is free to be able to get started with. And you can go over to our docs. You'll notice that there's a new section in fine-tuning, which is for GRPO. GRPO is a novel fine-tuning technique, particularly relevant for reinforcement learning, that came out of DeepSeek's groundbreaking R1 paper. The great thing is you can actually get access towards it now on the tip of your hands. If I go to the examples in the GRPO fine-tuning notebook, you'll be able to go ahead and follow along this particular data set I want to show you. Now, starting off with a data set inside of Predabase is pretty easy. All you're going to do is import in our client and put in your API token and load in your data set. Here you can see a bit of like what it actually looks like to do the countdown data set. I have a few different input numbers and a target. And the goal is, how do I actually use subtraction, addition, multiplication, and other operators to be able to write an equation that comes up with this target? Now, out of the box, what we saw were LLMs did not do particularly well in this task. And even using supervised fine-tuning does not really help the model performance whatsoever. Instead, the key for what I'm going to do with this notebook is use reinforcement fine-tuning. And one of the key aspects of reinforcement fine-tuning are the notion of reward functions, basically ways that we'll be able to incentivize and reward the model for correct behavior and penalize it for the wrong behavior. The reward functions operate over the outputs of the model. And so I'm going to define two off the box. The first is a formatting reward function. That's going to make sure that the model outputs are formatted as a reasoning model with think tags at the beginning and end, and then also follow a regex that we expect it to be able to match. And I'll get 1 point for every single one of those. We also have an equation reward function that checks a number of different conditions, like extracting out the answer and making sure that the answer is correct with what we have as ground truth. If it is, then the model will also get rewarded. And if not, we're not going to pass in any reward at all. Once I've defined a few different reward functions, I have everything I need in order to get started. Fine-tuning using our managed serverless GRPO option is as easy as just using adapters.create and then passing in the model that I want to fine-tune, and then a couple of the reward functions that I've written out as just Python functions above. Once I've done that, we'll actually be able to kick off a training job on a serverless GPU, as well as a weights and biases dashboard, where you can click in and get a sense of all the different metrics that exist. In this particular job, you can see things like after the first 200 or 300 steps, it started to get the formatting right. And then over time, it started to actually get other parts of the reward right as well. Unlike many of us who are familiar with traditional supervised fine-tuning, curves going up and to the right here are actually good rather than your traditional loss curves. Once your model is actually trained, you can start to spin up a deployment inside of Predabase very easily as well, just by saying create a deployment and then passing in the new GRPO adapter that's been created. And you can use this model for inference or for evaluation. So that's it. Everything you need to get started with reinforcement fine-tuning using the first fully managed serverless GRPO SDK. Can't wait to see what you all build, and please leave us any notes with your feedback. Thank you.